So this is the second page or the back side of your review for your test that we're going to go over, starting with number 9. Okay, so we're told that in the problem, this is what kind of a shape? A trapezoid. So even though you might think it's a parallelogram, it is actually a trapezoid. So if we look at the formula for a trapezoid, that's 1/2 of base 1 plus base 2 times the height. That's how we calculate the area for our trapezoid. So looking at the picture, what is the height of your trapezoid? The height is going to be 3. And what are our bases? Well, here's base 1, 4½ of x. And then here's base 2, x and 4. So we first need to figure out what the value for x is before we can actually put some numerical values to those entire bases. So how should we find the value of x? It's trigonometry, of course. Okay, so for 56.3 degrees, 3 is the opposite side and x is the adjacent side. So opposite and adjacent is the tangent. So tan of 56.3 equals 3 over x. Okay, the opposite over the adjacent is the tangent ratio. So because x is in your denominator, we're going to end up dividing 3 by the tangent of 56.3. And we get 2.00075, so basically 2. So if you showed me this on your test and you wrote down x equals 2.00075, but then you came in here as a 2, and how much is x divided by 2? That would be 1. 2 divided by 2 is 1. Okay, and then we did our area formula. 1/2 of, what's the top base? 4 plus 1 is 5. And what's the bottom base? 2 plus 4 is 6 times our height of 3. Okay, so now it's just a matter of figuring this out. This is 11. 11 times 3 is 33. So what's half of 33? I believe that's 16.5. And since we don't have any units, once again, we're going to have square units as our final answer. 16.5 square units would be the area of this trapezoid. Okay, moving on to number 10. Given the area of the parallelogram is 150, find the area of the rhombus. Okay, and we've done something similar to this before. And what do we notice about our double tick marks? That they're all the same. So we have 5, 5, and 5. The bottom one is 5 because it's a rhombus. And a rhombus is by diagonals get bisected, so the top and the bottom are both 5, which is fantastic. We know that the area of our rhombus is 1/2 of diagonal 1 times diagonal 2. So 10 is diagonal 1, and we're going to do some work in order to calculate diagonal 2. Okay, and it probably has something to do with this parallelogram. Since we were given the area of the parallelogram, we're probably going to have to use that somehow in order to find something that is useful to find our diagonal for our rhombus. So that's the parallelogram that we're talking about. It has an area of 150. And what is the base of our parallelogram? 5 is the base. So the area of our parallelogram is base times height. So I guess my base is 5, so that's 5 times the height. So this parallelogram has a height of, what's 150 divided by 5? That's 30. This parallelogram has a height of 30. So the question is, where do I put that 30? And if you're thinking about the side of your rhombus, you're dead wrong. Because everybody should know that anytime you're multiplying two things together to get you an area, they have to be perpendicular. And last time I checked, that is not a 90-degree angle. So this is not the height for your parallelogram. The height of your parallelogram has to be perpendicular to your base. This is the height of your parallelogram. It must be perpendicular to your base. Okay, so now we can do a little something. We have a right triangle here if you want to, and we can calculate your hypotenuse of your right triangle. But that's really the long way. Instead, the height here of your parallelogram corresponds to this portion of your diagonal. So if you get the height drawn correctly for your parallelogram, there should be absolutely no extra work to do in order to find the diagonal of your rhombus. Okay, if the top side is 30, and the right side is 30, that means the left side is 30, and we have a diagonal of 60. So half of 10 times 60 must be 300 square units as the area of that rhombus. 1/2 of 10 times 60, or 10 times 30, is 300. Okay, so it comes down to knowing that the product, your base and your height, must be at 90-degree angles to each other. And since your diagonals are also at 90-degree angles, you have yourself a rectangle formed by that shape there. Okay, such nice colors. Find the area of the rectangle. Okay, that's base times height. So we'll call this the height, and we will call this the base. Okay, and we have a whole bunch of angles. Whenever we have angles, that makes me think we're going to have to do trigonometry. And it's true, we're going to have to do trigonometry. So we're going to call this H. Yes, that's the height. And now we're going to break our blue section into two. We're going to call that much X and this much Y. Okay, so the base of your rectangle is going to be the X value plus the Y value. So let's set up our trig equations. For, I'm going to color this one green. For our green triangle, 3.6 is what side? 3.6 is the hypotenuse. Very good. So if we're going to make an equation that involves H, H is the opposite side, and this is the hypotenuse. Which trig is opposite and hypotenuse? That would be the sine. Very good. Sine of 56.3 equals H over 3.6. And since your variable is on top, we're going to times in your calculator. 3.6 times the sine of 56.3. Okay, so that's how you're going to find the height. Now let's figure out how we're going to find the parts of our base. X. X is what side of our green triangle? Well, it's the only other side left, and that's the adjacent side. So the adjacent side is the cosine. So cosine of 56.3 equals adjacent side X over hypotenuse 3.6. And once again, because the variable is on top, we're going to times in your calculator. And whatever that gives us, that's a pretty good job. And then similarly over here for your other right triangle, let's color it yellow. So here's our yellow right triangle with an angle of 59 degrees. So 5.8 looks like it's the hypotenuse, and Y looks like it's the opposite side. So that's making me think we're going to have a sine value The sine of 59 equals y over 5.8. So once again, we're going to multiply in your calculator 5.8 times the sine of 59. Now eventually what you're going to do once you calculate these things, we're going to take your y value, add it to your x value, and then multiply it by your height value. Okay, add x and y together, multiply it by h, let's see what you get. And I get an area of 20.872. Now if you were finding your things all along and you did this, you might get a little bit different decimals, but it should be really close to 20.8 or 20.9 or maybe even 21.0 something, depending on how much you rounded throughout. So to make sure that you let your teacher know what you're doing, show him or her the numbers that you're getting from your trig, your 3.6 sine and your 3.6 cosine and your 5.8 sine. Write those down, and then your teacher will understand what you're doing. Okay, number 12. A square has an area of 450. How long are the diagonals? So this one is our outside of the box thinking kind of deal. Because sure, we could figure out exactly what the side length is because area equals side squared. But what other kind of shape is a square? A square is also a rhombus. Okay, a square is a rhombus. Yes, it's a rectangle, but it's a rectangle with the same side. So it's also a rhombus. And a rhombus uses what in its area formula? The diagonals. So 450 equals half of diagonal squares. Since in a square the diagonals are the same, d1 times d2 is d squared, right? Because they're the same thing. d1 and d2 are equal. So in this case, we're calling a square a rhombus because the formula is much more conducive to finding the diagonals, since the rhombus involves directly the diagonals. So the math says multiply by 2 to get rid of 1/2. 900 equals the diagonal squared. And when I take the square root of 900, I get a diagonal of 30 inches is the diagonals. And since they're both the same, we can just call it one of them and we're good. 30 inches is the diagonal length. Okay, let's see what else we got. Back up to the top. Number 13. There we are. This is some algebra. One diagonal of a rhombus is 3 times as long as the other. Okay, so let's put some variables here. We're going to call d1 equals 3 times d2, right? One diagonal is 3 times as long as the other. So when we go into our area formula, which says area equals 1/2 of d1, and diagonal 1 is 3d2s, so 3d2 goes there, times regular d2, right, the second diagonal. That's how we get your formula. 1350 equals half of 3d2 times d2. Because we can only have one variable in your equation at any given time. So back to our algebra, times by 2, multiply both sides by 2. 2700 equals 3 diagonal squared. Right, diagonal 2 squared, it's the second or the shorter diagonal that we're talking about. Let's divide both sides by 3. 900 is the diagonal squared. And what's the square root of 900? Well, it's 30 again. Remember, this is D2, the second diagonal. So according to our chart up there, what's the first diagonal going to be? 3 times 30, which is 90. So we have the shorter diagonal of 30, and we have a longer diagonal of 90. Now our question says, how long are the sides? So hopefully you know the sides of a rhombus can be solved by using the Pythagorean theorem. Right, so we make our right triangle. And if my whole entire diagonal is 90, that means my triangle side is going to be half of that. And if my other whole entire diagonal side is 30, then my triangle side is going to be half of that. Okay, so this is using the properties of a rhombus that the diagonals get bisected, because we're trying to figure out what the hypotenuse of that right triangle is, aka the side of your rhombus. So 15 squared plus 45 squared equals c squared, using good old-fashioned Pythagoras. So the square root of 15 squared plus 45 squared into my calculator, and I get a side length of 47.434 feet as the side length of my rhombus. I think I said that twice. Okay, so we use the area to find the diagonals, and then we use the diagonals, chop them in half to make right triangles, and use our buddy Pythagoras in order to calculate the length of our side of your rhombus. Okay, and if it said find the perimeter, you'd simply multiply that by 4. Okay, now we have a kite. The shorter sides of a kite measure root 61. The bisected diagonal is 12, and the area is 96. How long are the longer sides? Okay, so here's your kites. We know the side length is root 61. We know the shorter thing got bisected, so we're going to chop it into 6 and 6. And we're trying to figure out how long are the longer sides of your kite. So we would like to once again do Pythagoras, right? If we can know exactly what this much of our diagonal is, that would help us set up a Pythagorean theorem, and we can solve for x. So let's do that using the area. We know the area is 96. So 96 equals half of 12 times that second diagonal. Okay. So in this case, I'm just going to do what is half of 12. Can we do 12 divided by 2 in our heads? Sure, that's 6. So if I divide both sides by 6, I have a second diagonal of 16. Okay, so the whole diagonal is 16. Is that what I'm going to use in my Pythagorean theorem? No, I can only use to there. So how am I going to chop up that 16? And it's not even because it's not a rhombus. If it were a rhombus, yes, it gets cut in half. But this is a kite, and that doesn't happen. Well, we are going to take our brains and use our buddy Pythagoras and figure out how much of that 16 is here. Right, by doing, let's call this y. So y squared plus 6 squared equals root 61 squared. And root 61 squared is just 61. So when we subtract 36 from both sides, 36 from a 61 is 25. And this little bit of our diagonal is 5. So this much is 5. The whole thing is 16. So the rest is 11. The rest is 11. So now we can do Pythagoras that says 6 squared plus 11 squared equals x squared. Very, very nice. So 6 squared is 36. 11 squared is 121. So x is the square root of 157, which, if you want to calculate that, is 12.53 approximately. And our units are just units, so 12.53 units. So this was quite a lot to this one, right? We used the area of your kites to find the other diagonal. We used Pythagoras to chop it into parts. And then we used Pythagoras to finally figure out what your longer side length was. Okay, lots of Pythagoras when we have right triangles. Okay, one diagonal of a rhombus is 6 units longer than the other one. So if one diagonal is x, then the other one is x plus 6, right? Longer, so we're adding. One diagonal is x, and then the other one is x plus 6. So if 80 is your area, 80 equals 1/2 of x times x plus 6. Okay. So we multiply by 2 to get rid of the 1/2. I don't want to half x. That's never any fun. So 160 equals, now I have to distribute. X times x is x squared, and x times 6 is 6x. And hopefully you have been able to recognize this as what type of an algebraic problem? A quadratic. So we're going to move our 160 onto this side by subtracting it, and we get x squared plus 6x minus 160 equals 0. Okay, and because this is an algebra class, sort of, we're going to have to factor this, and it should be a nice factorization. What numbers multiply to give you 160 and add to give 6? Hopefully you know that is 16 and 10, right? 16 times 10 is 160. 16 minus 10 is 6. So then our quadratic becomes factors of x plus 16 and x minus 10. And if we've done this for long enough, that means your answers are going to be negative 16, and your answer is positive 10. And since this is a geometry class, we can't have a negative 16 unit long rhombus. So then one of our diagonals is 10, and the other diagonal is 16. So we have diagonals of 10 and 16. Okay, so when you're multiplying together like you are on a rhombus, you're going to get a quadratic to solve. Hopefully your teacher is nice and gives you something that's actually factorable, which it should be, hopefully. I betcha. Okay, 16. One base of a trapezoid is 9 centimeters longer than the other. So once again, we have a base of x and a base of x plus 9. And it has a height of 10, and we know the area is 155. So we're going to use our trapezoid formula. 155 equals half of x plus 9, because you add your bases together, x plus 9, and we times it by the height of 10. Bless you. Twice. Okay, so there's lots of ways that we can algebra this, but what do you get when you combine your like terms in here? 2x plus 9, right? It's not 18x, it's not 11x. We cannot combine the x's and the 9, but you can combine your two x's. X plus x is 2x. So let's multiply by this 2 to get rid of 1/2. We know how to do that. 155 times 2 is 310. Okay, and now there's a plethora of algebra ways that we can do this also. One way is by dividing everything by 10. So let's divide both sides by 10. Okay, I can do that because I know that 310 is in fact divisible by 10, and it's something pretty. That number is 31. Okay, you could have also distributed your 10 and got 20x plus 90. But this is, we deal with a little smaller numbers like this. 31 minus 9 is 22. Divide both sides by 2 and x equals 11. So one of our bases is 11, and the 11 plus 9 is going to be 20. So we have bases of 11 units, or 11 centimeters, and 20 centimeters. So in a diagonals, if they were rhombuses or kites, you multiply them together and get a quadratic. But in a trapezoid, we are adding together, and you don't get a quadratic. You get a linear equation. And then number 17, the last one on this side, the area of a hexagon is the same as a kite with diagonals of 10 and 16. So area is 1/2 of 10 times 16. 160 divided by 2 is 80. So our hexagon has an area of 80. If the apothem is 4.8056, remember the area formula for a regular hexagon or any regular polygon is 1/2 the apothem times the number of sides times the side length. So the apothem is given to us as 4.8056. How many sides does a hexagon have? 6 sides. And do we know the side length? Nope, so we can call that x. So our side length is your variable. Okay, so let's put all of this stuff into your calculator. 1/2 times 4.8056 times 6. Let's see what we get when we do that. That gives us 14, that should not be in highlighter mode. 14.4168 equals 80. So let's divide both sides by 14, and that should give us our answer. 80 divided by 14.4168 is 5.54908. So we can end at 5.549 is your side length. And we are looking at centimeters. Okay, so when you're given the formulas, right, we can plug it in and we can solve stuff, or you can do the algebra and you're able to solve for different things about your diagonals or about your bases or, well, about anything really that goes into your formula. So hopefully that helps. Here's the second page as we prep for our polygon and quadrilateral area test.